Okay, welcome Joy and welcome Tammy. This could be a small group because the midterm is coming up. Some people already took it, but most people are not taking it for a little while. Um, I want to make a few announcements. One is you kind of must take the midterm by Wednesday, but I will make one exception. If you're scheduled to take it at Lake Tahoe Community College on Wednesday, and Lake Tahoe Community College is closed, which I would give it about a 75% chance, then I talked to the librarian and hopefully you can take it Thursday. But if it's open, then you got to take it. I don't know, Tammy, where are you coming from? Where are you logging in from?
Ukaipa.
Ukaipa, so you don't see what we're seeing. And Joy, I'm not sure where you're from. Uh, but
Yeah, I'm like 2 hours from LA, so
yeah, we're in a blizzard right now.
yeah.
And we're supposed to get 2 to 4 feet of snow in the next 48 hours. So
You guys have had a lot of that this year.
we've had a lot of that this February. It's
Yeah.
the biggest on recorded history. It's the biggest February of snow.
Wow.
Yeah. So again, I want to announce that. But again, if we're open, you got to take it if you're scheduled on Wednesday. But if we're not open, then of course we have to, figure things out. And I talked to the library; they will take a last minute, jump in on Thursday if you couldn't make it Wednesday because of the college being closed, because it wouldn't be your fault, of course. And we'll see. I give it about 75% chance for close on Wednesday. Well, but who knows? Who knows? Because three feet of snow, which is what they're 2 to 4, that's a lot. So that's just a note. The plan today is we're going to be going over chapter 10. So today is it's kind of one of the lighter days in terms of new material, and that's because you got your midterm this week. So I try to lighten up completely, and we have chapter 10, which is very similar to chapter 9. There's not a whole lot of new stuff to talk about, but I also want to get you going on the project. I've talked a little bit about the project already, but now is time to talk about the details because it's pretty much about chapter 10. So that is a plan. I'll also answer any questions you guys might have about the midterm or anything else. Chase and Richard, thanks for joining us. So Tammy asked a question about remind me again exactly what it was so I don't get it wrong.
I said, would we be able to get the midterm back so that we could study the layout of the question?
Yeah, so what I have actually created a key to the midterm. You can't see that right now because a lot of people haven't taken it yet. But as soon as everyone has taken it, then what I will do is I'll post the full midterm with the key on Canvas. And will that be enough for you, hopefully? Yeah, so that's the plan is to do that so you've got it all set up and you can look at it. Because again, you should be able to see it. If you really need to see your particular midterm answers, I can do that for you, but that's a lot. It's kind of a pain. I got to scan it in and email, but I can do it if you need it. But definitely the questions and the answers, the full solutions. So you'll be able to see what happened. So that is a plan. And again, I'm not going to start grading the midterm until I receive the midterms. So if a few of you have done the midterm, I'm not going to grade your midterm until everyone's basically done the midterm. I like to be consistent, and that way I can take the same amount of points off for the same mistake for everyone. Otherwise, if I grade today and then 3 days later I grade again, I might not be fair in terms of grading. So hopefully you understand that. So you have to be patient on that one. And again, if we get a blizzard and we're closed, then it's going to wait a little longer because we're getting a blizzard. It's pretty intense out there right now. Any other questions? Any other questions? Okay, I thought I always like to bring in a current event if I can. And as you know, Gallup is a nice, easy one. Oh, I wanted to mention something else. So not only is it a light one because we only have chapter 10, I decided not to assign a discussion post for this week. Because again, the midterm should be number one. And if you're done with the midterm, you can start working on the project. So you don't have a discussion assignment. It doesn't mean chapter 10 is not important. It just means that I like to lighten up the workload. So all you'll have is the secret word quiz, which should be really easy if you stick through another hour. And you'll also have the chapter 10 assignment, which isn't one of the harder ones. So hopefully that will make sense. And again, you got the midterm. That's hard. Okay. Any other questions? Okay, so let me share my desktop. I can get a current event. Again, it's my favorite thing about this class is that every single time I can go and grab something in 10 minutes from the news and pull it up and we can do statistics, where I can't do that in most of my other classes. So let me do that. I think it's that guy. All right, so hopefully you can see that. Let's go here and pop the chat. Good. Okay, so here it is. Most blacks rate race relations with whites as bad. Okay, but they give all kinds of stuff, and I want to kind of look at it, and maybe we'll do a hypothesis test. So here's kind of the results of a survey they've done, and you'll see that they asked a bunch of people. And for example, how would you rate the relations between various groups in the United States these days? Would you say relations are between blank are very good, somewhat bad, or very bad? And we have the relations. And here's the total percent for relations. Okay, and you'll notice that here's more Americans describing white-black relations as bad, keeps going. Majority of blacks for the first time describe black relations as bad, okay? So, which is too bad, we don't like to see that. We like to see good relations. Hopefully you all agree, okay, with everyone. We should all get along, okay? And if you go through this, we're gonna need some, you know how it is. We're going to need some numbers, okay? And they told us they have all kinds of survey methods, okay? So we got results based on a total sample of 4,578 non-Hispanic whites. They did 701 non-Hispanic blacks. So that's what we want to look at. So we got a sample size of 701, but I want to do a little more. I want to look at the Hispanics too, which was 760. So let me write down things. I'm going to leave this part. So the black sample size was 701. The Hispanic was 760. So I'm going to scroll up a bit. I want to compare the groups. Okay, something Gallup didn't do, but we can compare them. We can see, is there a difference between them? Because we got actually it's over here. There's most Americans. Here's majority of blacks. So you'll notice that the majority of blacks are this way. And we got good whites, good blacks, bad blacks. And then here's the majority of Americans. I don't know if they tell you Hispanics, do they? Let me see. Oh, actually, it's up here. It's how Hispanics feel about. So if we look at the Hispanics and we look at, let's go whites and blacks, you'll see we have 40% versus 52%. That's pretty different. Okay. If we look at that, can we say that the Hispanics, and we can look at it. Let's see. Can we say the Hispanics feel more strongly than the blacks? okay, about whites versus blacks. And you'll see we got a 52% for Hispanics. We got a 40% for blacks. So we got a hypothesis test. Now this is different than what we've done before, because before we just looked at one population, and we looked at one population's answers, and we said, was that a bigger number or a smaller number? Does that make sense? That's what we did last week. Now we have two populations. We have the population of blacks, and we have the population of Hispanics. And we want to compare the two populations' feelings about how whites and blacks interact. Does that make sense? And we want to say, is that a higher percent for the Hispanics than for the blacks in terms of the feelings? So let me write some stuff down because we've got to go and write some things in. So Hispanics are p hat was 0.52, and for the blacks, our p hat was 0.64. Any questions on that? Okay, so now what we can do, and we have our sample size, we got our p hat, we're ready to go. So now let me reshare. And let me go, and we got to type some stuff out.
I'm sorry, Professor, where does the 0.64 come from?
Just look at the screen. That's the Hispanics. I'm sorry, it's 0.52 and 0.40.
Okay.
I wrote it down. Yep, 0.40. Thanks a lot. Okay, so now I want to go to my paint. Let me find it. Where is it? There it is. All right. I need a blank screen to start typing. That's what I need. Okay, so what I'm going to do now is write the null and alternative hypotheses, and you're used to that. So again, the good news about chapter 10 is it looks really similar to chapter 9. Okay, here, but there are some differences. Let me go and it's a little too big. That's better. We have H naught, and H naught is that the proportion for the Hispanics is equal to the population proportion for the blacks. Any questions on that? So notice this is different than last week. Last week we had a proportion equals a number. Now we have this proportion is the same as this other proportion, and we don't know about either of them. So H1 is that the proportion for Hispanics. We want to find out if that is larger than the proportion for the blacks. Any questions on that so far?
Yeah, why larger than? Why not different than, or was that just a random choice? It could have been any
Pretty
other?
much. Yeah, I
Okay.
just needed an example. I could have done not equal to,
Okay, thanks.
but I decided to go for larger. Because they really want, because the article said that the blacks are really feeling low. Do you see that? So the question is, do the Hispanics feel higher?
I understand. Thank you.
So I kind of put it there, but you know, that's kind of random.
Okay.
Okay, so now what I do is I need to think about a level of significance. What do you think a good level of significance would be for this kind of study? Yeah, 0.05. I wanted to mention, because I was reading this morning, I looked at your answers to the discussion post for last week. Some of you are still confused about confidence level and significance level. Significance level is alpha, and it's typically 0.05 or 0.10 or 0.01. Confidence level is not for hypothesis testing. You don't use the word confidence at all when we're doing hypothesis testing. That's only for confidence intervals. Got it? Okay, so in particular, we can jump and do our calculator. So let's do that. And let me go to a new share so you can see the calculator. Okay, so what I'm going to do now is I'm going to pop in the numbers. So I need to go to stat. I need to go to test. You're used to doing this. Any guess on what we might need to go to for this example? The hope is you've been trained from last week to understand how to read these menu items.
It's a two prop because we're doing a proportion.
Yeah, and it's
We're doing
two groups. We got the blacks versus the Hispanics. When you have two populations, we're doing two prop.
But we don't have a standard deviation yet, so it would be the t-test?
No, standard deviation is only for quantitative studies.
Oh, okay.
And this was qualitative, right? Do you think the relations are good or bad? Does that make sense?
Yes.
It's not a number answer.
Yeah.
But a good point. You always want to think about that. So it's a two prop z-test. Z because we have a larger sample size. If you take the 701, for example, and multiply by 40%, you get bigger than 5. Hopefully you can just get that, because 40% of 700 is way bigger than 5. And similarly, 60% of 701 is bigger than 5. You also need the other ones to be bigger than 5, which is 52% of 760, which is certainly bigger than 5, and 48% of 760, which is also bigger than 5. So you need to have bigger than 5 for everything. So now there's 4 things to check and not just 2. So again, same idea, but kind of twice as many things to keep track of. So now we're going to go ahead and we're going to go down to the 2 prop z-test. I'm going to hit enter. It asks for x1. We're going to do a little calculation here. And again, it's very simple computer calculation. So x1 will be the, that was our Hispanic. So x1 was 52% of 760. And when I do that, I get about 395. N1, that's a Hispanic sample size, 760. X2 was 40% of 701. Which is about 280. N2 is 701. We want to see if it is greater than, which is what it says, but I want to remind you, go to greater than, hit enter. Color is not important. Any questions before I move to the next screen? Any questions? Okay, I hit enter. Okay, our test statistic is 4.6 about, and our p-value is it 2.03? Is that our p-value? What do you think? Yeah, it's not, because that e-6, very important. So it's actually 0.000002. So now I can go back to our write-up. And we can say, first thing, our p-value was equal to 0.12345 and a 2. And again, yes, this is new, but most of it's not. Are you feeling that? That this is kind of the same thing we did last week, but now we have 2 samples instead of 1. So that means we can, if your p-value is really small, what do you get to do? Richard and B Jazz and Joy, you keeping quiet. Okay, little p's. So we get to reject the null hypothesis. Okay, that's always what we're trying to do when we're doing a study. So now let's write down the explanation or the conclusion. So there is statistically significant evidence to conclude that the population proportion of Hispanics who and I guess it's are good, I think is what the proportion was, with black-white race relations. Oops, Balk. Is larger than the proportion of blacks who are good with black-white race relations. Any questions on that? Does this feel like a review of last week? Because this isn't supposed to be any very different, at least. Yeah, this is a review of last week, and what I said last week is that we spend the rest of the quarter doing hypothesis testing. So last week was the hard week because it was the first time you've seen it. Now we get to reinforce it. Every week we do more of it. Any questions on this so far? Okay, and again, we could interpret the p-value, the same idea. You would say, I'm going to just say it instead of type it out, but you would say that if the population proportion for blacks and Hispanics were the same in terms of how they feel about black-white race relations, and if we did another study of 701 blacks and 760 Hispanics, then there would be almost no chance, because that's what this p-value is, almost no chance that we would end up with at least 8% difference in the sample proportions, because that's what we got was 8% difference, okay? Or have the Hispanics being at least 8% more than the whites, thinking their relations are good. Any questions on that? Okay, and similarly for the, in this case it's not either direction because we have a greater than for our test. Does that make sense, Danny? Yeah, so that here we'd say the Hispanics are at least 8% more in favor, or more thinking that there's good relations because of that greater than sign. Had it been a not equal to, you would say that there'd be at least an 8% difference in the two. But in this case, it's more than. Okay, and similarly with the level of significance, we use a 5% level of significance, so we can say that if the population proportion was the same for Hispanics and blacks in terms of their feelings about having good black-white race relations, hard to say that. And if we did another study of 701 blacks and 760 Hispanics, then there'd be a 5% chance that we would end up falsely saying that the Hispanics have a higher population proportion that think that there's good relations. Any questions on that? No, in fact, the sample number for both groups, no, we didn't. We had 701 blacks 760 Hispanics. No problem.
No, I meant in your interpretation, if we did another study of 760 Hispanics and 701 Black, when you were talking about the confidence interval.
So it's the idea is if we did the same study.
Right, okay.
Right, with different people, but the same study.
Sure, okay, thanks. Sorry, I have so many questions.
Oh, no, that's the whole point of the webinars. Otherwise, what's the point of the webinar? Is to be able to do the back and forth and answer the questions as they come. So I hope that Richard and Joy and Jazz also have questions. Okay, I'm going to erase this so that I can put on the next one. But let me know if you not ready for it to be erased. I want to go select. Okay, so let's do another one. Okay, now it's not a current event. I usually do one current event, and then I can throw in stuff that is set up. This one actually posted it right. Sometimes I can't do tables well. Okay, so a manager wanted to see if people spend more money in her gift shop if they're given a free piece of candy when they enter the store. Have you ever been given a free piece of candy or a free something when you enter the store? Okay, so again, they do that for you, not because they like you and they want to give you candy. It's nothing to do with that. Okay, it's all about you give the free piece of candy, and then you hope because of that they're in a good mood, and maybe they'll buy more stuff. That's really what it's all about. And they'll tell their friends, come back to this store. Okay, that's what it's all about. So what we want to do is we want to see if this is a good idea or not. Okay, because managers care about that. All right, so we have receipts from the 12 customers who were given candy and the 12 who were not given candy. Let me ask you, is this a big enough sample size? Yeah, definitely not. You'd never do this. But there's a reason why I'm doing 12, because we're going to type this in a calculator, and I don't want to spend all day typing. In the real world, you're going to do a larger sample, more than 30 for sure, and then you don't have to worry about normality assumptions or any of that, and you can just go and do it. But we'll do it this way. Okay, so do we think that people spend more money? All right, so the first thing is let's write down the null and alternative hypotheses. So we have H naught. What's the big difference between this example and the last one? In terms of the null hypothesis, very important. What's the big difference? Any thoughts? Yeah, this is a mean, it's not a proportion. And I did notice that in your conclusions, when you were applying to each other's posts for the discussion assignment, some of you use the word proportion when it should have been mean. Some of you use mean when it should have been proportion. Pay attention to that, because that is something I take points off for. So in this case, because of that, we're not using P, we're using mu. And let's call it mu C for mu candy. So we want to find out if they spend more money. So again, this is a greater than. And then we're going to go mu sub n for none. Oh, sorry, this is a 1. H naught, let's put H naught over here. H naught always has an equal. And that is mu C equals mu candy. None. There we go. Any questions so far? Okay, we might use a 0.05 because, again, not a life or death situation. It's good enough. So I'm going to use 0.05. And what we want to do again is go to our calculator. I want to notice something here. Okay, you're just going to be looking at receipts from 12 who are given candy and 12 who are not given candy. It's just a bunch of people. The first person who was given candy has nothing to do with the first person who wasn't given candy. Does that make sense? We're not looking at couples or anything like that. It's just a bunch of random people. So they're not paired, and that's important because of the next example. So just note that. So now, as you might guess, we're going to go to our calculator because we can't do this without a calculator. So here's the calculator. Let me clear up what I had. I'm going to go to stat. I need to put my data in. I have data this time. So I'm going to enter data. I am going to clear out L1. I'm going to clear out L2. Then I'm going to go into L1. I'm going to just type my numbers in. So we have, what, 25. We have 14. We have 160. That person bought a lot. We have 98. We have 55. We have 18. We have 29. We have 44. 91. Then we have 83. And we have 17 and 32. And then for L2, we have 37. We have 51. We have 40. 37. 40 again. 22. 21. Then 9, 30, 28. And then 19 and 11. Okay. By the way, do they have to be the same number? Do they have to be the same sample size? Do you think you could do this if you asked, say, 12 customers, you gave them candy, and then 13, and you didn't give them candy? Could you do a study? Okay. The answer is yes. Not a problem. You don't have to have the same sample size, but again, you should have both samples bigger than 30. Okay, we didn't here because it would have taken too long for me to type it all in. Any questions so far? Okay, now I'm going to go to stat, and then I'm going to go to tests. What test do you think we want to use this time? Any thoughts? Just looking at the list. Yeah, it's actually 2SAMP. Yeah, 2SAMP. Not Z though, because we don't know any like population standard deviations or anything. 2SAMP t-test. Does that make sense? Okay, and again, my guarantee is we're not going to be using Z's for quantitative. We'll only be using T, because that's kind of historical why you use Z. So I'm not going to that. I'm going to go to the 2SAMP t-test, hit enter. Very important that we're in data. So I'm going to hit enter on data. My list 1 is L1, and my list 2 is L2. You could ignore the freaks, keep them as 1. We did have a mu1 greater than mu2. Hit enter. So in this class, by the way, and pretty much in the real world too, it's a no to pooled. So if you ever do yes to pooled, in this class, worry. Means you did it wrong. I won't give you anything with pooled. Okay, I want to stop and ask you any questions before I click calculate. So I don't want to go too fast. Any questions? Okay, so I'm going to hit calculate. All right. Notice the p-value is 0.033. The test statistic is about 2. So now I could go and state my conclusion because the p-value is 0.03, which is less than the level of significance. So let me go ahead and reshare. So notice that our p-value was equal to 0.03, which is less than 0.05. And now we can state the conclusion. And say there is statistically significant evidence to conclude that the population mean let's see, and it's a mean money spent at the gift shop is larger for those given candy compared to those not. Given candy. Any questions? Any questions? The hope is this looks real familiar. Again, very little new today. But the big difference is we have 2 populations we're comparing to. Any questions on that? Any questions? All right, let me give you the next type. It turns out there's 3 types of problems that we're doing today. So I want to, as always, type in the chat box or say stop if you don't want me to erase it all. Because I need to clear it out so we can get to the next example. All right, going once, going twice, gone. And now let's do the next one. Okay, so here's the next one. Are people better listeners if they do not have use of their eyes? Okay, 12 volunteers were first given 100 words to remember while they were looking at the person speaking. Then they were given 100 words while blindfolded. Each time the participants were asked to write down as many of the words as they could remember. The table below shows the outcome of the study. Okay, I have a question for y'all. What's the big difference between this example and the last one in terms of the statistics? Obviously, it's gift shop and blindfolded, but that's not the interesting thing. This one still means, actually. This one still means, right? The survey question is, how many words did you remember? It's a number. It's not a yes or no. Any thoughts? Richard, Joy, Jazz? Zach? Okay, here's the big difference. Okay, in the last one, we had a bunch of people who were given candy and a bunch of different people who were not given candy. In this one, we have a bunch of people who were not blindfolded, But then the same people were also blindfolded. So we're looking at two responses from the same person instead of separate people. Very important. So there's a link. This 14 and 17 as these first numbers, they're linked. If I switch the 14 and 23 in order, that would actually change the study because the link would go away. So we call this paired data. Yeah, same person for both answers. Okay, so if it's one thing giving two answers, it doesn't have to be a person, by the way. It could be a dog, for example, doing two things. Or it could be a date where two events happened on that date, like weather in Tahoe and weather in Big Bear, if you know where that is, on each of, say, 12 days or 30 days. You could do the same idea and say which one's colder. But as long as they're linked by the date, then we're talking paired. Yeah, so by you, actually, very close to where I grew up. Okay, so that's why I know where you're from, Tammy. Okay, so they're linked. And if they're linked, we call them paired or dependent. Okay, and when you have paired or dependent data, everything is different. Even the null and alternative hypotheses are different. Actually, let me go to brushes. So let's write down H0. And what we can do is we can say that each person has a difference. The first person had a difference of how much? 3, or probably -3, because you probably do 14 minus 17. That's how the calculator will do it, by the way. It'll do L1 minus L2. So we're going to call that mu D. And that is the mean of the differences. All right, well, if there isn't any, if looking and being blindfolded give you the same things in terms of the means, then what should the differences be on average? Yeah, but the differences. Because if you subtract two numbers and they're the same number, what do you get? 0. Right? If they're supposed to be the same and you subtract, you better get 0. And that's so we get mu sub D equals 0. And then we're going to have H1. And that is going to be mu sub D. That's an awful mu, but that's okay. And now we want to see if, now we have to look at this. Are they better listeners if they don't have use of their eyes? So notice the first person. I like to look at the first person. Does the first person match that? Was the first person better without use of their eyes? Yes. Okay. And if you subtract 14 minus 17, you get a negative number. So that means mu sub D will be less than 0. So you always want to look at one that exemplifies what you're trying to show and then do the subtraction. If it's a negative number, you write less than 0. If it's a positive number, you write greater than 0. Okay, if you want to show there's a difference, you write not equal 0. Any questions so far? In this class, I'm not going to give you anything other than where it says 0. Sound fair? But I will tell you it does happen sometimes. The one time that would happen is, let's suppose you're an elementary school teacher. Maybe you teach 2nd grade. And you give a test on the first week of school, and you give a test on the last week of school. and you have this new technique that you think is going to be amazing. You don't want to show that you've done better than nothing. Does that make sense? You want to show you've done better than a whole grade level up. So that would be example where mu sub d would be equal to 1, because you've increased by 1 grade level in that year of time that you're teaching. So in the real world, sometimes, not often, but sometimes you don't have a 0 on the right-hand side. But most of the time it'll be 0, and I won't give you anything on a test that doesn't have a 0. Sound good? Okay, the only time you would not have a 0 is if you want to show improvement more than a certain amount. Okay, or vice versa. If you want to say, oh, it goes down more than a certain amount. Okay, but most of the time it's going to be 0. All right, so now we're ready for a calculator. The calculator is going to look very different this time. Not the calculator, but the calculator buttons we hit. Not going to look different. Calculator look exactly the same. So let's go ahead and do a new share. And let's clear out what we have. All right, so what I'm going to do is I'm going to go to stat. The beginning is the same, actually. I go to calc. That's right, I go to edit. That's what I meant. I'm going to erase what I had for L1 and L2. Okay, and then I'm going to type in all the numbers just like I did before. And again, I'm just doing 12 because, you know, normally you want more than 30, but I don't want to spend all day typing. So we have, what, 14. Oh, didn't make it. Let's try again. That's better. And then 23, and then 15, and then 37, and then the person only remembered 4, and then 19, and then 22, 51, 37, 18, 16, and 22. And for L2, we had 17. And then we had 25. And then we had 20, 37, 3, and then 29, 24, 53, 35, 20, 19, and 22. Any questions so far? All right, now comes the part that's very different. First thing I do is I need to leave the screen. So I'm going to go quit. Second mode is quit. Now what I'm going to do is I'm going to do the following. You want to follow along. If you have a calculator, it'll really help. I'm going to go second 1, which is L1, and then minus second 2, which is L2, and you hit this STO button. That means store it into. And then second 3 is L3. This is the first time we're using L3 in this class. Any questions so far? Okay, now I hit enter. Okay, what did the calculator just do? Any guess? Yeah, just subtracted. And we have a new list. And in fact, you don't have to do this, but I just want to show you. If I go to stat and edit, notice L3 has all the subtractions. Any questions on that? Okay, it didn't find the mean of all the numbers, it found the difference of all the numbers, Joy. Does that make sense? It found the difference of all the pairs of numbers, actually, is a better way of saying it. So L3 is all the subtractions. So what we've done is we've taken a study that had 2 variables, and now we only have 1 variable, and that's the variable of the subtractions, or the differences. which means that we're back to last week, because we want to show the differences are less than 0, right? So we just have the one variable of differences. We want to show that's less than 0. And we know how to do that. We go to stat, we go to tests, we just have one variable. Do you remember what we used when we only had one variable? Again, think last week. That's the hint. Okay, prop was when we had one variable was a yes-no question. But these aren't yes-nos. These are differences that have numbers. But it was a good try, Tammy. Okay, we use a t-test. Do you remember using the t-test? That was when you did a hypothesis test for just one population. And that's what we've got now, one population. It's a population of differences. And I hit enter. I have data. U0 is 0. My list is L3, so second 3. Freq is always 1. And we want to show that these differences are less than 0. So I go to less than. Color I don't care about. And I hit calculate. So let me ask you, is any questions about what I've done so far before I leave the screen? Any questions? Okay, so I hit enter. And there we go. Today's the day of low p-values. So we have a p-value of 0.018 about, or 0.02 even. And now I can state my conclusion. So there is statistically significant evidence to support the claim that the population mean number of words remembered is greater if the person is blindfolded. Any questions on that? Any questions? No questions? Okay, if there's no questions, I want to change up a bit. This is pretty much all we need to do in chapter 10, but there's a big thing coming up in a few weeks. What is that? Yeah, project. So the project's coming up. That's the next big part of the class. The midterm might be coming up for some of you. It might have already happened for some of you. I still have, here, this is, where are they? Over here. There we go. These are the midterms that have already come in. What do I have? 4. So 4 have come in already. And I should be getting a whole bunch more later this week. And project is next after that. So let me go and share my desktop. And let me go to Canvas. And actually, before I do that, I think I want to go back. So I just realized, where was it? There we go. something I'd like to do so I don't forget. Any guess? Yeah, secret word. Okay, or a secret rod. And the secret word of the day is difference. Because what we're talking about is either the difference between two population means or the difference between two population proportions. So everything in chapter 10 is about differences. Any questions on that? All right, so now I'm going to go back to Canvas. And there's a few ways of finding it. One is going to syllabus. And let's go to project 2, because now we're ready. It's due March 17th, by the way. So seems like a long time from now, but it will come up fast, 2 weeks from Sunday. And it doesn't sound long now, but it doesn't sound quick now, but it will come up. So I'd say after you do the midterm, that's when you start thinking about it. Couple things. First is you can partner with anyone you want. You can keep the same partners. You don't have to keep the same partners. But don't assume your partner is still going to want to partner with you. Make sure you contact your partner. Okay? There's some people that aren't in the class anymore. So your partner might not even be in the class. So make sure that you contact your partner. Okay? There is a Project 2 discussion forum now, by the way. All right, so here's what the purpose of Project 2 is: to use confidence intervals and hypothesis testing. Are you surprised? Isn't that what we've been doing the last few weeks? To support or show lack of support for a research project, you must first decide what you're interested in researching, then design your study, and then collect your data. Then you analyze your data and see what it tells you about whether it supports your hypothesis. Okay, very important in terms of the order. Number 1 is find partners. Okay, 3 is best. Number 2 is decide on your hypothesis. What is your null hypothesis? What is your alternative hypothesis? Okay, all this happens before you get any data. Okay. Number 3, after you've decided on the hypotheses, is to think about what the type 1 and type 2 error ramifications are. Okay, we kind of went over this last week, but now it's time to do it for the project. Number 4 is based on the ramifications. What is a proper level of significance? Okay, don't just say 0.05 because that's what it always is. It should be based on which is worse, type 1 or type 2 error. And if they're about the same, then you go for the 0.05. Okay. Then after you do that, okay, you could even write the first page of your project at that point, because there's a lot right there, maybe 2 pages, okay? And I'm not even talking about the cover sheet. Then what I recommend you do is post on the Project 2 discussion forum. Post your hypotheses and post how you're going to collect your data. And if you have a survey question, what your survey question is. This is very different than the last project. This is not project 1. You are welcome to not do a survey and collect data. So there might be data that you can find online, for example, okay, or find some other resource. Doesn't have to be a person's answer to a survey question. Okay? But it does have to be a quantitative study, and it has to be a comparison study. It could either be a comparison study for independent samples or dependent samples. So in other words, it could be like the example 2 that I did today or example 3 that I did today. Okay? And I don't mean looking versus blind, but the point is it's quantitative. You're comparing two populations, and it might be paired, it may not be paired. Okay, any questions so far? Any questions? Okay, the problem with which flavor of chips do you like is that's not quantitative. Does that make sense, Joy? If you ask me what flavor of chips that I like, I might say I like, you know, barbecue chips. I'm not going to say 37. Okay, so that's important. Think about the survey question, and if it doesn't have a number, answer. And it's two survey questions or two populations. And if the answer isn't a number, then it won't work. Very important. So I'm glad you asked. Can it be a study of more than one comparison, but we choose out of them like the gal? Yeah, that's still one comparison. Okay, but you have to have the data, the individual data. So what we didn't work because that was yes or no question, right, Tammy? Okay, in terms of the data, you have to be able to get the data. If you can get the population data, it doesn't work. So if you could easily get the population, it won't work. So if you wanted to look to see, you know, who scored more runs on average per game in, you know, 2018, was it the Mets or the Yankees? The problem with that is it's very easy to find out in the 162 games that each played what the runs were. So there's no sample that you need to do because you can get the population really easily. So if you can easily get the population, it won't work. Okay, but it can be, it doesn't have to be a survey question. For example, you could do in Tahoe, our big thing is Lake Tahoe clarity. And you could go find data on the clarity on the North Shore versus the clarity on the lake on the South Shore. And you can get that from the UC Davis Resource Center and do a comparison. Does that make some sense? And you can go online and find it, and that's fine. And you're not going to find, you know, clarity on every moment that ever happened in the world. You're only in Lake Tahoe. You're only going to be able to find samples that were taken. Any questions so far? Like the same place, but two kinds of crime as an example. If there's a number, it has to be quantitative, not did the crime happen. But if you wanted to look at, I don't know, car thefts versus house thefts, if you could find the data on how much money was taken or what was the worth of the money taken in the two types, that could possibly work. If you're not able to get all possible crime that happened. Does that make sense? Okay, so you would have to get numbers for each thing. Okay, so in what you're doing, you give me the sampling technique. That's short, unlike the project 2. Unlike project 1, project 2, the emphasis is not on the sampling technique. Just kind of state it, and that's good enough. You don't have to do like multiple paragraphs on it. Okay, any questions so far? Okay, you should do, by the way, you should find a client. If you can't find anyone that cares, it's not a very good project. Just one page for the sampling technique part. Typically, it's around 8 pages for the project. Okay, you're going to collect statistics, and you're going to put it in a spreadsheet. Just like project 1, you must use a spreadsheet. And just to let you know, I made it so it works for project 2 also, but it's a little different. Let me go to it. It's usually the first one up. Yep. So project 1 was this first tab, One Veristats. Any guess on what project 2 is going to be? Yeah, 2 varstats. Okay, so I'm going to erase those. Maybe I'll even ask you a survey question. We're going to have a sample size of 4 if everyone answers. But my guess is some of you are not answering because some people are a lot quieter than others. All right, I'm going to ask you a survey question. I'm going to ask you 2 survey questions because I'm going to do a comparison study, and I'm going to do it paired. Okay, so my first survey question is, how much time did you spend studying for the midterm? And the second survey question is, how much time did you spend in your writing of project 1? So type it in. All 4 of you should type it in, by the way. 2 numbers. First is how much time did you spend studying for the midterm? Let's go hours. How many hours did you spend? 7 for the midterm. And Richard, how much time did you spend for project 1? Timing was 22 and 40. And let's see what we got. So again, you have to give me 2 numbers. Let's see what we got. Richard, here we go. Project 1, 20 hours, 7 hours for the midterm. Oops, 7 and 20. And Joy was 5 for the midterm. And 15 for the project. And then let's see, Katie, I think we don't have yet. Katie was 10 for the midterm. And let's see, Katie, how much for the project? I don't see it in there. There we go, 12 for the project. Okay, even though I think they're worth the same, or maybe the midterm might be a little more if you study more, you work more on the project. It's interesting. Okay, so you'll notice everything's there for you.
You missed JBAS. They were 8 and 10.
8 and 10. Thanks. Ah, I see. Wait, 8 and 10. We'll just put it in. I just need numbers. Okay. So the most important thing, is to be able to move your eyeballs to the right place. So for this example, is this independent difference or is this dependent difference? Which one is it? What do y'all think?
Oh, I want to change my answer. I said independent, but I think it's dependent because it's the same person giving 2 answers.
Yeah, I think there's groupthink here because I'm seeing independent from everybody. It's dependent. It's one person. You answered 2 questions. That's dependent, right? We're comparing midterm versus project, and it's the same people answering 2 questions. It's not 2 groups that we're comparing. Do you see that? So this is dependent. You have to move your eyeballs to the right place. You don't have to do any menu stuff, but you have to let your eyeballs move right. Okay. Yeah, this study is dependent for sure. There's nothing independent about it. Okay, so then we can go to stats for dependent difference. So I have a mean difference of -9. We have the standard deviation of the differences, minimum Q1. These guys are less important. This one's really important. So we have a p-value. You have to decide, is it Two-tailed, right-tailed, or left-tailed? Again, it's all there for you, but you have to read the right one. So it depends what our hypothesis was. If our hypothesis was that people spent more time on their project, then we're looking at a left-tailed test. And that would be a p-value of 0.02. Okay, level of confidence. So again, we're doing a confidence interval. For confidence intervals, it's left-tailed because we're trying to show that people spend more time on their projects. And if they spend more time on their projects, then that means that midterm minus project is negative. And that's left-tailed, because negative is on the left side of the number line. Okay, for the confidence intervals, you can start at 95, and that'll give you the confidence interval. Okay, you should look at it and decide, is that what you want? First thing, that means that you have a 5% chance of being wrong, and here's our spread between 0.3 and 17.7. Well, that's huge, and maybe you don't want that huge spread. If you go to 95, I go to 90, you'll notice the spread changed a little bit. Maybe you're happy with that. You should talk about in your project, compare. Okay, I recommend not looking at 90, 95, and 99. In our class, we stick with those because that's pretty standard. Notice it's big because what was our sample size, by the way? Yeah, it was 4. Okay, might have been 5 because I might have put some extra numbers in there. Okay, first thing, you're not allowed to use a sample size of 4 or 5. What must your sample size be? Not 30, but 31 is fine. It's always bigger than 30. Not at least 30, but bigger than 30. And that starts at 31. Okay? Now, if you're doing dependent, that means 31 people answering 2 questions. If you're doing independent, that means 31 people answering a question, 31 other people from the other type answering the question. And it doesn't have to be people, by the way. Remember, it could be like clarity of the lake. It could be temperature. Okay, it's not always a survey question for this one. This is not project 1. Any questions so far? Then there's this baby, the standard error. Standard error is essential. Remember the standard deviation in project 1, and that was like the most important of all? The standard error is the most important for this project 2. It's also going to be the most difficult part of the project for you. Okay, it's the hardest to understand. So the standard error gives you an idea of how accurate your sample difference is compared to the population difference, how good a predictor it is. So we had a standard error of 3.13. So that means that your prediction might be off by as much as 3 hours. Do you see that? Could be off by more, but just kind of an average amount that it could be off by doing, in this case, samples of size 5 over and over again. Then you can see it's a lot. What about comparing how long someone spends outside versus how long do they spend inside in hours a day? Yeah, that could be something if you have an interest in that. And if you can think of someone who has an interest. That, of course, that would be a survey. So standard error is really important. There are 3 places standard error comes up. And it's the most important places. One is it's how good a study you've got. And that's what I just talked about. The other is how satisfied are you with the conclusion for your hypothesis test. So in our case, we had a p-value of 0.02. When you get a p-value of 0.02, are you satisfied? Yeah, you should be satisfied because that means you rejected the null hypothesis. You got it. Do you see that? That's your dream, is to reject the null hypothesis. So you should be satisfied with a p-value of 0.02. Is that clear? All right. What if we got a p-value of 0.06? Would you be satisfied? Yeah, you can't reject and you're close, which is the most frustrating of all. All right? So that means that you're very unsatisfied. And the reason why things went wrong is the standard error. And what's the only way of reducing the standard error? Yeah, larger sample. Okay, which is a bummer because that means you got to spend a lot more time getting the data. Does that make sense? Now, of course, this is on theory. You're not going to actually get more data, but this is what you'll talk about. What if you got a p-value of 0.9? What do you think? Yeah, you hang your head, but do you get another, do you try to do it again with a big sample? No. I like to think about it as like a soccer game. All right? If the p-value, if you're playing soccer and you're ahead 2-1, there's 3 seconds left in the game, and your big player is about to kick the ball into the goal, and someone fouls him, and the ref doesn't notice. Do you complain? Do you yell and scream saying it's not fair? Right? You don't. Why not? No, not because it takes the goal game, because you won the game anyway. Right? If you got the foul, you might win 3-1, but who cares? 3-1 or 2-1, you still won the game. Just bad sportsmanship. Does that make sense? Okay. Similarly, and that would be like a p-value of 0.02. You won. Don't argue. Okay. What if, on the other hand, you were down 2-1? Same situation. 3 seconds left in the game. Your player gets fouled. The ref doesn't call it. And you don't get to kick it. Okay, then you argue. Does that make sense? Okay, it's a lot of work to argue, but then it might be worth it. Okay, that would be like a p-value of 0.06. You're really close, but you still lost. Okay, what if instead you were losing 12-1? 3 seconds left in the game. Your player's about to kick it and they get fouled. Ref doesn't notice. Do you argue? No. Again, bad sportsmanship. You lost the game. Give it up. Same thing. If your p-value is 0.8, it's over. You lost the game. Don't try again. You're happy with the standard error. You may not be happy with the outcome, but you're happy with the standard error. The truth has been revealed. Okay, so you need to talk about that. For confidence intervals, we noticed that we looked at this confidence interval, and what you said is, oh my God, the spread is big. We're not getting much information because we have such a big spread. So the only thing you can do to reduce the spread is to do what? About the standard deviation. You need to reduce the standard deviation, the standard error. You reduce the standard error by increasing the sample size. So if you're unhappy with the confidence interval because it's not giving you information, because the spread is too wide, then you say the standard error was too big. Do you see that? So you could actually have a project where the standard error was too big in one paragraph, the standard error was small enough in another paragraph. Because looking at the p-value is very different than looking at the confidence interval. This was an example where we had both. Any questions on that? Okay, so standard error is really important. You need to have a lot in your project on it. You will lose a lot of points if you don't fully explain the standard error. It's not about the formula. That's less important. Okay, just a note, you don't need to have any graphs. This is not about graphs, but you do need, if you're doing stats for dependent difference, you need to copy this and paste it in your project. If you're doing stats for independence differences, you need to copy this one and paste it in your project. Does that make sense? Those are the biggies. Okay, sometimes you might be interested in the mean for A and the mean for B. You don't have to share the spreadsheet. Again, if you have copied and pasted it in, which is really easy, then you don't have to worry about the sharing. Because then I'll see that you use a spreadsheet. And that's better because it's easier to refer to it if you can see it right on the paper. It'll be easier to read. Okay, you don't need to put the data itself in. I don't need to see your data, but I do need to see this stuff. Any questions at all on that? Okay, just want to let you know, this is really important. This project is all about the difference. Okay, if you don't have the word difference in, probably at least 10 times in your paper, then it's not going to be good. And it's not like 10 is this magic number or anything, but it's all about the difference between the two population means. So every reference should be about the difference between the population means. Got it? So that's essential. Okay, so again, confidence interval for the difference, hypothesis test for the difference. That's what it's all about. These guys are the biggies. Just like project one, throughout the entire paper, you have to talk about what decisions the client is going to make after having seen the results, not just in the conclusion. So every result you look at, talk about what decisions we made because of it. Okay. You could talk about what assumptions did you have to make. Okay. Again, if you had a big sample, you don't need to assume a normal distribution. Don't make that mistake. Okay. The only time I'll allow you to have a smaller sample is if you're doing a project that is truly useful to you and you can't get data that's a sample size larger. Okay, so if you're going to have to convince me that it's useful. So that might be, for example, if you're working for the Forest Service and you're working on a project right now, although right now the only project up here you'd be working on is shoveling snow. But if you're working on a project right now and you only had, say, 25 of each type, then I'll accept it. Does that make sense? Okay, but it has to be very specific, where it's for your job, not just because that was your project and you were interested. Okay, your boss had to tell you you had to do this. Okay, and by the way, I really like projects where it's actually something you need to do. Okay, something that's truly going to be useful to you. Okay, and to your work or to your whatever you're doing. Or if you're taking a psychology class right now and you have a paper due in psychology to compare some kind of, I'm not a psychiatrist or anything, but compare some kind of mean, some kind of attitude scores for different types of people. And you only had that many people, then you can do it lower. But if you can do something that's truly useful, that's better. Does that make sense? Okay, and the rest is kind of similar to the other project, but the main pieces are right here, these big fat paragraphs. Confidence interval, hypothesis test. That should be most of your paper. The rest I just kind of glance through. Confidence interval, hypothesis test, and standard error. I have a whole video just on the standard error. I recommend you watch it because so many people have trouble. Any questions at all? Because we're just about out of time. It was actually longer than I thought it was going to be. Sorry about that. Any questions at all about anything from project 2 or anything else? Because we're pretty much done with the what I had to say. Okay, and by the way, same rule, give it to me a few days before. Okay, same time, Wednesday at 8, I guess. Then I will look it over and give you a review and help you out. If you don't, good luck. Any questions on this? Okay, just to note, people who came back and talked to me like 5 years after my class, every single one of them said the most important part of the entire class to them was the projects. That's what they used in their, you know, future major or their career or whatever. That's what made the class useful, because it's real. Any questions? So as always, if you don't have questions, we can say goodnight. And I'll go, oh boy, looks like we got 6 inches of snow, just like in the last few hours. I'm skiing home, so I'm okay. I got a headlamp too. Yeah, quick question about the midterm. And you're one that hasn't taken it yet, I think. So what's your question? You could talk to if you want. Maybe I'll even stop the share. Are the questions laid out like the homework? No, the questions are laid out like the midterm shell. Do you remember that? Yeah, so I literally copied, I just took the midterm and I erased a few things and left the rest. And that is your midterm. There were a couple of them just said problem like this chapter, but most of them weren't. So make sure you practice lots of problems like the shell, because that's the midterm. So I didn't type much of anything new other than paragraph here or something. Okay, other questions? Tammy or Katie or Richard? Okay, well, Katie, have a good night then.
I think I'm good, Professor. I was just trying to think about different topics for the project, but it's going to take longer than this video. So you have a good night and get home safe.
Yeah, make sure you talk to your partners about the ideas too.
Sure. Thanks. Have a great night.
All right, well, have a good night. And for all of you who are watching this as an archive webinar, I hope y'all have a really good night. If you live up here, stay safe in the snow. If you don't, stay safe in the rain, I guess. Please ask questions if you have them.